All right, so we're going to just go through this worksheet and some of the examples. So I give you guys a word bank up here. So these are pretty much all of the different reasons that we could have. You may run into different ones at times, like if you're given an equilateral triangle or an isosceles triangle or a square, you may have to use definitions of those. But these are kind of the common ones for angles and segments that we're going to be using. So the first ones you should all pretty much know. Definition of congruence is basically if I have something like angle 1 is congruent to angle 2, and then I want to talk about their measurements, I can change this to measure of angle 1 equals measure of angle 2. And I can use the definition of congruence. I can actually do that backwards too. If I have the measures, then I can say they're congruent. That's the definition of congruent. It also works for segments. So if I had like segment AB is equal to segment AC, right, then I could say that AB is congruent to AC. Right, so like the length, this is saying the length of AB is equal to the length of AC. Now I could say that the segment AB is congruent to the segment AC. So that's the definition of congruent. Segment addition postula is pretty easy. It's basically if I have, A, B, and C, then I'm saying that, AB plus BC equals AC. Notice that I didn't put any lines over it and I didn't use congruent. Angle addition is the same thing. For angle addition, if I had 1, 2, and then A, B, C, I could say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Right, so this top angle plus the bottom angle is equal to the overall. Okay, definition of a straight angle would just be if you have some straight angle here, like angle 1, that's 180 degrees. Definition of supplementary angles, right? If you have two angles that are forming a straight line, then I can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Sometimes we'll say that they're a linear pair first, and then we'll say, because they're a linear pair, then we use the definition of supplementary. Okay, a definition of complementary is if you know that two angles are complementary. Right, now that I know that they're complementary, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Okay, definition of a right angle is just that if I have a right angle, then I know that the measure of that angle is 90 degrees. Definition of a midpoint. So if I knew that, say, B was a midpoint between A and C, then I could say that AB is congruent to BC. That's the definition of a midpoint. Same thing for an angle bisector. Right, if I had A, B, C, and D, if I knew that BD was my angle bisector, well then I know that angle ABD, right, from A to B to D, that's this top one, would be congruent to angle CBD or DBC. You name it either way, DBC, CBD, same thing, as long as B is in the middle. Okay, definition of perpendicular lines. If I knew that two lines were perpendicular, then I know that my angles are 90 degrees. Okay. Vertical angle theorem we've talked about is if I have angle 1 and angle, say, 2 over here, I can say that angle 1 is congruent to angle 2 by the vertical angle theorem. Then we have two new ones, congruent supplement theorem and congruent complement theorem. You don't have to memorize these, but they're basically just shortcuts for the transitive property. So I'm actually going to show us the congruent complements theorem in one of these examples, and then we'll come back and show how to do it as a shortcut. All right, so let's go through. Example 1 is asking us to prove the vertical angle theorem. So I'm going to make a statements and reasons. So if I'm proving the vertical angle theorem, I can't actually use it. Okay, so I'm given that angle 1 and angle 3 are vertical. I'm going to put a 1 here. Okay, so my reason for this is that it was given. Okay, so then next I could say that angles 1 and angle 2 form a linear pair. And actually, I'm going to even make this a little bit easier and just say that they're supplementary because they form a linear pair. So angle 1 and angle 2 are supplementary. I'm going to shortcut this and just put sup. And in the same step, I'll put angle 2 and angle 3 are supplementary. Right, and my reasoning for that is that the angles form a linear pair. So then from there, I could say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And I could also say the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And this would just be the definition of supplementary angles, right? The definition of supplementary angles. Okay, so I basically said, yes, they're next to each other. That's a linear pair. Or they're supplementary, right? I could have kind of switched the statement and the reason there. It's kind of the same thing. But this is important to say that the measure of angle 1 plus the measure of angle 2 is 180. Now I'm writing kind of big, so I think I'm going to run out of room, so I added a little statements and reasons over there. But next, this is the transitive property, but I also could have used substitution. Is if I know that the measure of angle 1 and 2 is 180, and then another measure of angle 2 and 3 is 180, then I know that I can set them equal to each other. So I can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And really, you could have I put transitive property, but you also could have put substitution. Okay, so this is, I'm calling it the transitive property because remember the transitive property is saying if something is 180 and something else is 180, then those two somethings are equal to each other. But, you know, what you could have called it substitution as well because basically, you know, this 180 here, you know, and you have a 180 here, so you're replacing this guy right into that 180, and so then you could have called it substitution. So either transitive property or substitution property would have worked for that reason. Okay, so now what I'm going to do is I don't want measure of angle 2, right? Because what's my goal here? My goal is to get angle 1 equal to or congruent to angle 3. So I want to get rid of these angle 2's. Well, I could subtract, you know, measure of angle 2 from both sides, right? We could subtract that. And so if I subtracted that, that would give me the measure of angle 1 is equal to the measure of angle 3. And so that was just the subtraction property. Oops. Subtraction property. Okay, now, that's almost what I want. I don't want them equal, though. I want them congruent. So my last step is just going to say that angle 1 is congruent to angle 3. I can always change back and forth between the measurement is being equal and then the angles being congruent. And we do that just with the definition of, if you're lazy like me, just put definition of congruence like that. Okay, so now, that was a lot of work, right? Now, though, you don't ever have to do that on your own. What you can do literally, now that we know this as a theorem, is a much easier way to do this would just be to say statement and reason. And to literally just say, okay, number 1 is angle 1 and angle 3 are vertical angles. Why? Because that was given. And then literally, if I know they're vertical angles, I can just say angle 1 is congruent to angle 3 because of the vertical angle theorem. So if you're lazy like me, you'll kind of just abbreviate it like that. So next up, I'm going to show you guys the complementary angle theorem. And so congruent complementary angle theorem. So I'm going to try to write a little smaller on this one. So statements and reasons. And so again, kind of the long way to do this would be to say, okay, I know that the measure of angle 1 plus the measure of angle 2 equals 90. And the measure of angle 3 plus the measure of angle 2 equals 90. right? And so that was given. And so then I could say, from there, using that transitive property, if they're both equal to 90, I could say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Why? Because of the transitive property. Okay, so I know that didn't quite come out nicely. Let me write this below so it's a little bit easier to see. So equals the measure of angle 3 plus the measure of angle 2. I kind of ran out of room there, but I'm just setting this equal to that by the transitive property. So then from here, now I could do the same thing. I could subtract off angle 2 from both sides and get measure of angle 1 equals measure of angle 3. Right, I just subtracted out measure of angle 2 and measure of angle 2 to get rid of it. Okay, so then from there, that was our subtraction property is what I did. Right, and then finally I could say that angle 1 is congruent to angle 3 by the definition of congruence. And you could totally do this, and this is something that you could prove every single time. But that's, 4 steps. And so mathematicians are lazy, and when they can do something every time, they kind of make a theorem for it. So what we do is we have a theorem that makes this a lot easier. And that's going to be the congruent complements theorem and the congruent supplements theorem. And so what these say is the congruent supplements theorem says if two angles are supplementary to a third angle, then the two angles are congruent. And the congruent complements theorem says the same thing, but with the word complementary. Right? So if two angles are complementary to a third angle, then the two angles are congruent. And so here, I know that, okay, the measure of angle 1 plus the measure of angle 2 was equal to 90 degrees. And the measure of angle 3 plus the measure of angle 2 is 90 degrees. So that was given to us. And so then I could just say that because of that, right, angle 1 and angle 2 are complementary, are complements, and angle 2 and angle 3 are complements. Why? That's the definition of complementary angles. And so what I can say is by that theorem, I can say that angle 1 must be congruent to angle 3. Why? Because angle 1 is a complement of 2, and angle 3 is a complement of 2. They're a complement of the same angle. So that's the complementary, or the congruent complementary theorem. Right? And if you mess it up, I always forget it says congruent complements. If I said congruent complementary, I'll still give you points. But that's the congruent complements theorem. Right, and so that's a little bit quicker. Sometimes I do not have to remember to go through transitive and subtracting. But either one of these proofs, right, would get full credit. You could do this one on the left, or you could do it this way on the right with the theorem. Okay, so let's do another example. We have angle 1 is congruent to angle 3. That was our given. So I'm going to make my statements and my reasons. And our goal is to prove that angle 6 is congruent to angle 4. So sometimes when I'm planning these out, right, I'm going to write in my given, but sometimes I don't actually write out everything. I kind of try to do it by hand first up here and just kind of think, why are they congruent? So I know that angle 1, I'm going to put in an angle symbol. Angle 1 and angle 3, those are congruent. And I want to prove that angle 6 is congruent to angle 4. Well, what else do I know? I'll put this in another color. I know that angle 3 has to be congruent to angle 6. Why? Those are vertical. So I'm going to just kind of put this up top. Angle 3 is congruent to angle 6. Why? Vertical angle theorem. Okay, and then I also know that angle 1 has to be congruent to angle 4 because those are vertical angles. Well, now I have a 1 dash everywhere, so I can prove that each of those 4 are equal by the transitive property, right? The transitive property is kind of showing me if things are equal, then we can equal them to other guys. So, from there I can just use the transitive property to finish this. So that's kind of a lot of times how I plan it, is I just kind of plan it by just writing it up top, and then I start trying to get my reasons. So the first thing that I did was I said the vertical angles. So I'm going to say angle 3 is congruent to angle 6. And you can do these at the same time if you want to. So I could say like, and angle 1 is congruent to angle 4, right? And I'm just combining them because it's the same theorem. So I have the same reason. But if you wanted to put this in a step 2 and a step 3, you could. So the vertical angle theorem. All right, then from there, now what did I say next? Is I said, well, now that I know all of these things, now I could kind of use my transitive property. So I could say, okay, angle 1 has to be congruent to angle 6, right? Because I see how I have like a 3 and a 3. So I could say angle 1 must be congruent to angle 6, right? Because I'm basically getting rid of, the 3's and putting in the 6 in its spot. And then same thing, I have a 1 and a 1. So I could put angle 4 into the 1 spot and say angle 4 has to be congruent to angle 3, right? Why? Either substitution works or, the transitive property works, right? It's kind of the transitive property is just substituting. And so then from there, now I can see that, okay, I wanted to get angle 6 being congruent to angle 4. Well, now I can kind of do the same thing, right? As I know that angle 1 is congruent to 4, and now I know angle 1 is congruent to angle 6, so I can kind of put the 6 in there, so that angle 6 is congruent to angle 4, again, because of the transitive property or because of substitution. All right, so there's that one. We'll do one last example, okay? And this is given that triangle RDA and triangle CTB are equilateral triangles, and also given that RD is equal to TC, prove that AC equals DB. So I'm going to kind of, I might even do this one big here so I don't run out of room this time. So we have our statements and our reasons. I'm going to put a 1 in here and just put in all of my givens. So triangle RDA and triangle CTB are equilateral triangles. That was given. And then RD equals TC, that was also given. I put these as 2 lines. You could have kept them as 1 line if you wanted to. So what do I know from that? So again, I said before I make my plan, I'm going to kind of, or before I write my proof, I'm going to plan out, using the picture. And I want to get AC congruent to DB. So that's my goal, is that AC would be congruent to DB. So I know they're equilateral triangles. So I know that this, AR is congruent to the entire AD, which is congruent to the entire, RD is congruent to the entire AD. So that line is going for that entire line right there, right? Now, I don't know if those are equal to the other side, so I'm going to put those with 2, right? 2 for that line, 2 for that line, and 2 for that line. So kind of, I know that my blue triangle is an equilateral triangle, and I know that this red triangle is an equilateral, but I'm not sure yet if they're equal to each other, right? It didn't tell me that they were equal to each other. But what it did give me now is it did give me that RD, right? RD is congruent to TC. So if I do know, right, that basically TC and RD are congruent, now by the transitive property, now I do know that they're all the same. Right? So kind of from there, I'm trying to get AC and DB, right? Well, I can't get AC right now, but I could get AD and BC, right? Because AD is part of the blue triangle, BC is part of the red triangle. and this is a little bit tricky, but once I know that, then I can use angle addition postulate, right? AC plus CD would equal to AD, right? Like this little part plus this little part equals the whole. And then I could get BD plus CD equals BC, right? Doing like this little part and this little part. This is kind of a confusing one. And so then from there, by the transitive property, I could say that AC plus CD equals BD plus CD, right? Because I know that these two are equal, so I can kind of plug that in. And then I could subtract out the CDs to cancel those out. So this is a really long, kind of tricky proof. I'm going to try to go by it one by one as much as I can. But that was kind of me just planning out what I knew I wanted to do. So I'm going to go ahead and kind of erase this stuff just so make it a little bit cleaner. Okay, so what I know is if it's an equilateral triangle, I know that all of my sides are equal to each other. So what I can say is, you know, if I'm looking at this RD, right, well, if it's an equilateral triangle, that would be equal to AD. So I can say RD equals AD. Now I'm going to do the same thing for the other triangle, right? TC, that's the side that they gave me, is equal to this other bottom side. So, and TC equals BD. Why? That's the definition of equilateral triangles. Oops, 3. Okay, so then from there, now I know that those two sides are equal to each other, right? RD and AD and TC and BD. Now I want to get the bottom sides equal to each other, right? Because that's my goal eventually is AC and DB, which are on the bottoms. So right now, though, my bottom is AD and BD, those full lengths. So I'm going to say AD then must be equal to BC. And I miswrote this one. It wasn't BD, it was BC. So be careful there. Right, it was BC, that entire length. So AD must be congruent to BC, right? The bottoms are equal to each other. Why? Because of the transitive property, right? If you're confused on the transitive property, it's whenever you have like a repeat. See how I have RD and RD repeated? So I can say AD equals TC. But I also have TC and TC repeated. So I can plug in, basically I'm plugging in AD where I see the RD and BC, or even up here really. AD where I see the RD and BC where I see the TC. Right, so that would be the transitive property. Or substitution works as well. Right, I'm substituting in AD for where RD's place was and BC where TC's place was. So now I know those bottoms are equal to each other. Now that's not quite what I wanted. I didn't want AD, I wanted AC. Well, how can I get from AD to AC? I can say that AC plus CD equals AD, right? That's like this left side plus that right side would equal to the whole. Right, and then at the same time, I'm going to do the same thing with the right. Right, this right side plus that left side would equal the whole. So that's BD is the right side plus CD is the left side equals BC is the whole. Right, so that is my segment addition postulate. All right, and then from there, right now, again, I know that AD is repeated. BC gets repeated. So I can plug in AC plus CD there and BC plus BD plus CD there. Right, so I can say AC plus CD equals BD plus CD, right? Again, that's the transitive property where I'm just plugging them in like they're each equal to another item. Or you could also call it substitution. And I'm almost there. I want AC equal to DB. Well, I have AC and I have, BD. And so I just want to subtract off CD. So AC equals BD. That's what I wanted. Now I'm just going to write these because they wanted them as DB. I'm just going to rewrite these as DB everywhere I see it, just to make it look exactly the same. It doesn't matter, if you call it BD or DB. It's just kind of choice. But since they're calling it DB, I want to call it DB. Okay. And so this was we just subtracted, right? We just subtracted off CD from both sides. All right, and there's our proof. So for homework, I know these are confusing. I definitely do tend to get confused sometimes. So on some of these, I did give you kind of a fill in the blanks. So like this first one, you're given AC is 31, the whole is 31. And then I'm kind of giving you different reasons. You'll have to fill in everything. All of your reasons will be in this word bank up here. So you're just going to take this word bank, and all the reasons should be up there for the most part. Number 2 is a little bit tricky, but number 2 is actually very, very similar to this one if it was just the bottom piece of it, right? So I actually kind of already did number 2 down here. You should be able to kind of figure it out. It's very similar, where I give you that AL is congruent to SK, and we want to prove that AS is congruent to LK. So you're going to use that segment addition postulate and the transitive property. Okay, so you have to do that one on your own. Number 3, again, I give you some stuff to fill in, right? So I tell you that angle ACB and angle BCE, right? That's the 5x1 and the 9x plus 41, form a linear pair. And you just have to kind of fill in the reasonings. And then number 4 is that BD, so this line BD, bisects angle ABC, and I want you to prove that angle 3 is congruent to angle 4. So you are going to have to use the bisector theorem, and then also the vertical angle theorem and the transitive property. Okay, so kind of, bisector theorem saying that they're congruent, vertical angles are congruent, and then transitive property. Number 5, again, is filling in. And I want you to prove that angle 1 and 4 are we're given that angle 1 and 4 are complementary. I want you to prove that angle 2 and 3 are complementary. When it says VAT, that's the vertical angle theorem. Right? And then 6, you're given that angle 1 and angle 2 are complementary, so you can kind of put like a 90 in there. And then you're also given that angle 1 is congruent to angle 3, and that angle 2 is congruent to angle 4. But you don't necessarily know if 1 and 2 are the same. Now I want you to prove that angle 3 and angle 4 are complementary, that they add up to 90. Okay, so this is going to involve kind of the transitive property, and that's substituting. And then the last one, you're given that DG is 11, and that GF is 11. And you're asked, and you're given that GF, so GF would be here, is congruent to EF, so that those two sides are congruent. Right, so that would mean, by substituting transitive property, EF should be 11 as well, right? And you want to prove that DG is congruent to EF. So this one's pretty basic. It's just kind of substituting or using that transitive property. So this one shouldn't be too hard. So that's our homework, is to do those 7 questions. Some of them are fill in the blank, some of them are on your own. And then we will go over these tomorrow.